In this video we're going to look at proxy models in Django applications, and these are Django model subclasses that allow you to customize the Python behavior of the model. Now an example of that in Django would be to maybe add a custom manager to the model class and override the default manager for that Django model. But you can also add custom functionality to your model classes depending on what you're trying to achieve with the proxy model. And examples of that might be custom methods and custom logic around the query sets that are retrieved from the database. Maybe you want to change the ordering, or maybe you want to filter out some rows from the data. So proxy models allow you to create these classes that operate over the same database table, but the Python level behavior of the models is changed. And we'll see examples of that in this video. If you're enjoying this content, give the video a thumbs up and subscribe to the channel for more, and let's dive in. So let's start with a look at the Django documentation on models. Now models are the definitive source of information about your data, and how your models are defined, these map to database tables in the application. We're going to look at a very specific type of Django model, and that's proxy models in this video. And if we go to the table of contents on the right hand side, there is a section here on proxy models. So let's quickly read through this, and then we're going to move on to writing some code in Django. So when you use multi-table inheritance, what happens is a new Django database table is created for each subclass of a model. So that's the typical way of doing things in Django. And we did a video on multi-table inheritance that should be appearing on the screen now. And this is usually the desired behavior, since the subclass needs a place to store any additional data fields that are not present on the base class. So if we go down to the code example, we have a Django model here called person, and then we have another model called 𝗏person that inherits from the above person model. So what happens here is that we have inheritance on the second model, and normally in Django when you define another model class that inherits from a parent model, the fields on the parent model, such as first name and last name here, these belong in the person database table, and the subclass, in this case 𝗏person, can define its own fields, and any extra fields that are not on the parent will be stored in the table for that subclass. So that's two database tables, and we have multi-table inheritance with that approach. But what a proxy model does is slightly different. And we use proxy models when we only want to change the Python-based behavior of the model class. And that can be to change the default model manager or to add a new method to the class. And that's what proxy model inheritance is for. We create a proxy for the original model. And with our proxy models in Django, we can create, delete and update instances of that proxy model, and all of the data is going to be saved to the database as if you were using the original model. The only difference here is that you can change things like the default model ordering or the default manager in the proxy without having to alter the original class. So if we go down here, you can see how a proxy model is defined. Within the subclass here that inherits from person, we define the standard Django meta class, and we're setting proxy to true. And the very important point is that we're not doing multi-table inheritance. The subclass 𝗏person, that operates on the same database table as the person class. So even though we have two Django models here, we only have one underlying database table, and that's because the second one is a proxy model. They operate over the same data. And what the proxy model does is it allows you to customize the Python behavior, and we're going to see examples of that in this video. Now in order to see that, let's go to VS Code, and I'm in a models.py file here, and we're going to define a class, and that's going to be a Django model called task. And that's going to inherit from Django's models.model class. And let's define a couple of fields on this model. So we're going to have a name for the task, and that's going to be a car field. And we'll give that a max length of 100. We're also going to have a field called created at. So let's create that now, and that's going to be an instance of the models.datetime field. And we're going to pass auto now add and set that to true, in order to automatically add the current time when a new task is entered. And I want to add a final field here to the task model, and that's going to be a models.integer field. But what I want to do is set this to a set of choices that we're going to define just above this task class. So let's define a new class above here, and this is going to be a class called task status, and that's going to inherit from Django's models.integer choices class. And an integer choices subclass is kind of like an enum in Python. It contains a predefined set of choices that we can apply to our Django model field. And I'm going to paste some task statuses in here, and we're going to have 3 of them. First of all, we have to do. Secondly, we have the in progress status for a task. And finally, we have the completed status. So what we're going to do in the task model is we're going to set the choices for this status field, and we're going to reference the task status integer choices subclass, and that has a .choices property. So that means that these choices are the ones we want to use for the status field. And finally, in this class, let's define a _string method, and I'm going to return self.name for the task. So when we print out a task, we want it to show the task's name by default. So that's the models.py file for now. We have the task status integer choices, and we also have the task class itself that's going to map to a database table. Let's now make the migrations for this application, and we can do that with the make migrations command. And once we've done that, we can run the migrate command, and that's going to create the database in this application. Now once the database is created, what I'm going to do is take this task model and I'm going to add it to the admin.py file. So from core.models, let's import the task model, and we can register that with the admin using the admin.site.register function, and we can add new tasks to the admin. So in order to do that, I'm going to quickly create a super user, and we can do that with manage.py create super user, and I'm going to give the super user a name of admin. And finally, we can run the server and go to the Django admin on the browser, and in this admin UI we can go to the task model, and at the top right we have a button to add new tasks to the database, and I'm going to add a set of tasks to this database now. So I've now added 5 tasks to this database, and you can see them here on the admin UI. Now what I want to show in this section of the video is how we can query these tasks and how we can filter by the status. Now we have on the model the status field here, and that's going to be one of these. What I'm going to do now is go to the scripts directory, and I have a script in this application called proxymodels.py. So let's open that, and by default that is just a run method that prints hello to the terminal. But what we're going to do now is we're going to actually use the task model, and we're going to use the Django ORM, and we're going to query the database and get back a set of tasks depending on a particular status. So at the top of this file, I'm going to bring in the 2 imports from core.models of the task model and the task status choice class. And then let's say we want to fetch all tasks that are in progress. What we can do is we can use the task model and we can filter down the tasks. So we're going to use task.objects.filter, and if we want to get all tasks that are in progress, we can filter on the status field, and we're only going to get the tasks whose status is equal to in progress. So let's print those to the terminal when we run this script, and I'm going to expand the terminal below here, and we're going to use the Python manage.py run script command, and the name of our script is Proxy Models, and when we run that we get back the 2 tasks that are in progress. So we have a task called Learn Python, that's in progress, and we also have a task called Read a Book. And it's very easy to change what we're getting here, so if we wanted to get all tasks that are completed, we can rerun the command, and this time we get the task Go to the Gym, and apparently in this system that is completed. Now while this kind of filtering might be easy, if we are often differentiating between the different statuses, and we want to provide different behaviour for models based on the status, what we can do is we can create the proxy models for this task. So let's see an example of that now. Let's go below the task model, and we're going to define another model now, but this model is going to be a proxy model, and we're going to call it in progress task. And because it's a proxy model, it's going to inherit from that parent task model, and that's the concrete model that has the database table under the hood that this proxy model is going to use. So let's define that now, and again, as we saw in the documentation, we define the inner meta class, and we're going to set proxy to true. Now what we're going to do in this in progress task proxy model is we're going to redefine the manager on the model. So as you probably know in Django, if you have a model you can call the .objects manager, and that's the default model manager for a model in Django. We're going to redefine that in this in progress task proxy model, but first of all we have to actually write the manager itself. So I'm going to create another class in this task, or rather in this proxy model, and that's going to be called manager, and that's going to inherit from Django's models.manager. manager. So we're creating a custom manager that we're going to use here, and we're going to set the default manager for the proxy model to something different from the parent task model here. So let's keep going with that. If we go back down to the manager, we're going to override the default getQuerySet method, and I've got some code completion going on here. What we're going to do is we're not only going to return super.getQuerySet, but we're also going to add a filter statement to that, because in the in progress tasks, if we want to fetch all tasks that are in progress, we need to filter that down automatically, and we can do that here by overriding getQuerySet. And again, as we did in the script, what we can do is filter down by the status, and we're going to filter to only tasks whose status is in progress. So that is our manager with an overridden getQuerySet method. We can then set that manager on our class by setting objects to an instantiation of this manager. So this is our proxy model, and we can query the database as we normally would with the task model using this proxy model. So I'm going to copy the name of the model, and let's go back to the script here, and at the top let's import that, and the query that we're executing here with the task model, I'm going to comment that out. And if we go below here, I'm going to reset the in progress variable, and we're going to use the in progress task proxy model, and this time we can call .objects.all. And the reason for that is because by default this should only return the tasks that are in progress, and that's because the manager that we've defined here in the proxy model is overriding the getQuerySet method and doing that filtering automatically. So let's now expand the terminal, and what we're going to do is clear this out and rerun the script, and we should get back only the 2 tasks that are in progress. And the reason for that is because we've extracted that functionality to a proxy model. So when we call the proxy models.objects.all function, it's going to return all of the tasks that are in progress. Now, as we said earlier, when we have the proxy model, in this case in progress task, it is going to get that data from the same underlying table as the parent model, which is task. But what we've done in Python is we've customized the behavior of the class itself by adding some extra filtering to the manager. Now, as well as tasks that are in progress, we might want to create proxy models for the other 2 task types that we have. So we have to do and completed as well. What I'm going to do is copy the name of this class, and we're going to paste the code below, and I'm going to create a couple of extra models. So let's start with the to do task. Again, that is going to be a proxy model, but we're going to change the functionality or the logic that's defined in the model manager. And all we have to change here is the status. Because we want to get back only tasks whose status is to do, we can set that here in the filter method inside the manager's getQuerySet method. And I'm going to do exactly the same for completed tasks. So the only difference is the name of the class, and the status that we're filtering on here, that is now set to completed. So let's save the models.py file and go back to the script here. We now have 3 proxy models, and I'm going to import these at the top, and that's going to allow us to use these within the script. Now I'm going to add a couple of print statements here, and we're going to separate these with some lines. So at the top we're going to get all tasks that are in progress, and then below that we're going to get all tasks that are completed, and then finally we're going to get all tasks that have a status of to do. So let's start with the completed tasks. I'm going to create a variable here called completed, and we can use that completed tasks proxy model, and we can call .objects.all to get all of those, and then we can print those completed tasks to the terminal. And we can do the same for the to do tasks. We have a proxy model now called to do tasks, so let's copy that, and we're going to execute to do task.objects.all, and that will give us back a list of to dos that we can then print out to the terminal, and that's all we need to do in this script. So let's expand the terminal now, and we're going to execute this script, and we now get back this output. We can see at the top the tasks that are in progress, and that was learn Python and read a book. We have the single completed task, and that was go to the gym. And finally we have a query set here of tasks whose status is to do, and that is the tasks to order food and to learn a language. Now these query sets have been generated on the proxy models, and that means that instead of querying using the parent model, which in this case is this task model, where all the database data is stored, we now have the proxy model that alters the functionality at the Python application interface. And all it's doing is providing some filtering at the moment, but we can do much more in these proxy models in order to differentiate between different types of a particular entity. Now let's show an example of something else we can do. Let's say if we have some tasks in the database that are marked with a status of to do, we might want to get back a different ordering when we query those tasks than we get back for the parent model or the other proxy models. And it's very easy to add a custom ordering to a proxy model. all we can do, or all we need to do, is go to the meta class and use the ordering property. And I'm going to set that to a field on the model. So let's use the field created@, and what that's going to do is return the tasks with the status of to do, but they're now going to be ordered, and that means that tasks that were created a while ago are going to appear at the start of that query set, and that might be what you want. That might allow you to identify tasks that have had a status of to do for a long time. So what you can do in your proxy model is you can add a custom ordering, and that can be different for in progress tasks. We might want to order by name, for example, or any other fields that are defined on the parent model. And let's show one final example here. With our proxy models, we can also set defaults, and an example of that might be when we create a new instance of the proxy model. Let's show how to do that now. We're going to override the Django 𝗬 method, and as well as taking self, we can pass the arguments and keyword arguments into the 𝗬 function. Now we're overriding this 𝗬 on the in progress task proxy model, and what we're going to do within this 𝗬 method is we're going to check whether the model that we have, the instance, is being added to the database for the first time. So we can do that by looking at self, and then that has a property _state, and that property has another property called .adding, and this is going to be true if the instance is being added to the database for the first time, and it's going to be false otherwise. So we're checking if this is true, and if we are adding a new task to the database using this in progress task proxy model, what we're going to do is automatically set self.status, and we're going to set that equal to task status.inProgress. And that makes sense. We have the proxy model for in progress tasks. If we call in progress task.objects.create, because we're creating a task that's in progress, it makes sense to set the status of that task to in progress when we first create the object. So we're doing that here, and we're only doing it when we create the object for the first time and add it to the database. And then after that, we can simply call super.save and pass the args and quargs into that. So this is a simple modification to the 𝗬 method on the proxy model itself, and the purpose of that is to automatically set the status and the resulting row in the database. Now we can see an example of that in action, so let's go back to our script here, and I'm going to clear this code out of the script. Now what we're going to do is take this in progress task model, and we're going to call the .objects.create method. So let's reference the model, and we're going to call .objects.create, and because the status is automatically set, we only need to pass the name in here. So let's say we have a task in progress, and that's something like watch Star Wars. We pass the name in there, but we don't need to worry about the other fields. And if we look at the other fields, we have the created@ field, and that's automatically set in the database whenever the row is entered into the table. And we also have the status. Now normally we would have to set that, but because we have this overridden 𝗬 method within the proxy model that we're actually using here, that's going to automatically set the status on creation. So let's now print this task to the terminal, and I'm going to print the status of the task as well. So let's expand the terminal, and we're going to run the script again, and you can see that we have the task created here called watch Star Wars, and it has a status of 2. Now why is the status 2? Why is it not set to in progress? If we go back to models.py, the reason for that, you might remember, is that we're using an integer field here, but we're setting choices on that, and we're using this integer choices subclass here, and number 2 represents in progress. Now there is a way in Django to get the human readable name for this enum, so let's go back to the script, and I'm going to add another print statement here, and instead of just printing task.status, we have a function that we can use, and that's the getStatusDisplay function. So basically, if you want to use the human readable name of a choice in Django, you take the name of the field and you can surround it with the get_name_display function. So for example, if we had a choice for the name field, the name of the function would be getNameDisplay. So let's see that in action as well. I'm going to expand the terminal, and this time, as well as the number 2, we get back the status of in progress. Now the key takeaway here is that we have a proxy model, and we're using that proxy model to create a new instance of the task, but automatically set the status on creation. So if we look at what the proxy model in progress task is doing, we have a custom manager, and whenever we query the table, it's going to automatically filter the query set to only the tasks that are in progress. And now, as well as that, we also have an overridden 𝗬 method, and when we create a new task in the database, if we use this proxy model and we're adding it for the first time, it's going to automatically set the status field to in progress. So what we're doing here is amending the Python level behavior of these classes using proxy models. And you can override any Python behavior you want. You could set custom functions on each of these proxy models that are not shared among the other ones. But under the hood, it's going to operate over the same database table as the other proxy models and as the parent model. Now we also saw how we can set a custom ordering on one of the proxy models. Let's finish with one very simple example. We're going to use the completed tasks class. So this proxy model, let's say we wanted to get a different string representation for this proxy model. What we can do is override the _string method, and we can provide our own implementation of _string that applies only to the completed task proxy model. So what we're going to do is return the name of the task, and we're going to add some sort of message here in brackets, and that is going to say congratulations, you completed this task. So if we now save this and go back to the script here, what I'm going to do is remove this code, and I'm going to add a print statement here, and we're going to use that completed tasks proxy model, and we're going to print out all of the tasks that are completed, and hopefully we're going to see this custom implementation of the _string method for each of the completed task instances. So let's test this out, and this is the last test we're going to do in this video. We're going to run the script, and hopefully we're going to see this time that we get back not only the name of the task, but we get this custom message as well, because on this proxy model we have overridden the _string method and provided our own implementation for completed tasks. And again, just to hammer the point home, what we're doing here is modifying Python level behavior, and that's because we're overriding a method on the model instance. But all of the data that's going to be used by these proxy models is going to come from the same database table under the hood. And that's all for this video. If you have any other ideas for how you can use proxy models in Django, let us know in the comments, and we might consider making some more videos on this topic. And just to summarize, proxy models can be useful to differentiate rows that share a database table, but if there's a common use case for filtering based on a database field in that table, you might want to extract things to a proxy model. So if you have any custom behavior that you need to apply to your Python objects based on the particular value of a field in the table, these proxy models can make sense under those circumstances. So thank you for watching. If you've enjoyed this video, please give it a thumbs up on YouTube and subscribe to the channel for more Django content. And if you're finding this content useful, consider buying the channel a coffee. We have a link to the 𝗏𝗏𝗶𝗶 page below, and we'll see you in the next video.